Ok, bonjour. Alors, on va attaquer aujourd'hui le deuxième exercice. Oh, pas ici. Cet exercice-là, le deuxième exercice du livre de Shreve and Karatzas, Brownian Motion and Stochastic Calculus. This exercise say that if we have a process X with the sample path that is RCLL, in French we say CAD-lag, which means right continuous left limit, okay, on 0 infinity. Then if this process is CAD-lag or RCLL, then the event A, if A is the event that X is a continuous on 0t, like the question show that A appartenant to fx t0. Okay. So first, what is this is the natural filtration is defined in the book above, okay, and it's written here in this book. So fxt is sigma, the sigma filtration generated by the processes xs and x until time t, and means is the smallest sigma filtration with which xs is measurable. Okay, the smallest filtration which make these processes measurable. It means xs minus 1 of all open sets on the state space appartenant to the sigma algebra of the sample space or the part space. Yeah, one can see the definition of measurable function. Not measurable, but measurable. So, and here, roughly speaking, if we say a set or event appartenant to fxt, that means that an observer of x, someone that observes x, knows whether or not A has occurred. So here, A, which is the event that x is continuous, it's clear that if someone observes x, he will not see if it's till time t0. He will see if x was continuous till time t0 or not. This is what it means here. Yeah, so this is trivial, but how can we prove it? Because if we have processes, we can observe the path, and the paths are we can see if they are continuous or not. Yeah, so we have this information. So how to prove this? Let's write something here. First of all, we had x. Oh. This is a bit thick. We have x. X is CAD-lag, or here written in English, right continuous left limit. Yeah. Why we need this assumption? Because imagine that x was not CAD-lag. If x was not CAD-lag, yeah, not RCLL, and we wanted to see if the paths from of x from 0 till t0, if the path there was continuous or not. Yeah, but then we will have to see for every t, we have to see for every point, for every point t on interval 0 t0, we have to verify if it's continuous or not. But then we have an infinity of points here. Yeah, and if we have an infinity of points, it's too much information to handle for sigma algebra, or for this sigma algebra. Okay, we cannot see for all the points, for instance, and make the intersection. We don't know if the intersection, for instance, of all these points or union of all these points are in this sigma algebra. So it's very important to have RCLL, in the sense that, why? In the sense that, as we done in the first exercises, if we have this right continuity and limit, the process doesn't have a discontinuity of a bad discontinuity. Yeah, it has a good discontinuity. And in plus, because it's right continuous, what we know that limit of x t, for instance, for in t converger t1 of x t1, if we continue, so it's continue, right continue, if t greater than t1. Yeah, so t greater than t1, it means we can write this like this. We can write this here. That t coming conversion from top to t1. Yeah, this we hold. Yeah, and here, as we saw, we can, instead of taking all the t's, it's enough to take some tn's that are in q, to pass to work in q in this. And q, we know that q is dense in R, so we will have the results. Yeah, so what we done now, instead of working with infinity of points here 0 t0, we will work just for some point that there are in q. And q, it's countable set, so the information, the union, the intersection, is still in the sigma algebra. Okay, so here the definition here of continuity as a, the event A that x is continuous, we can see it in the following manner. Yeah, we can see it in the following manner. This set A, we can write it as intersection of all t in 0 t0. So we will work till a certain interval 0 t0, because 0 t0 is excluded, so we will work in the interval 0 t, okay, such that t less than restriction of t0. So we'll work in a closed interval like this. Everything is good. Yeah, so here intersection of all this event omega for all. So the definition of continuity, but we will, instead of taking epsilon just in 0 infinity, to have countable information, we will take our stuff in q. So we take epsilon positive, but just the with irrational number exists delta, yeah, also positive, and also enter the set Q, yeah, such that if you converse or for S, we will write it in the following: for every point U in 0 T enter Q, for all S and U minus delta, U plus delta enter Q, yeah, enter Q. You should be careful here to not exit the interval T0. We have XSU XS omega minus XU omega, these two processes. If S is near to U, XS also it's near to XU. Okay, we have these things. My writing here is not very good. A bit. Okay. So, and here it's we can write it in the following manner. For instance, when we have for every epsilon, it means intersection of epsilon up in 0 infinity 1 times v. Here it exists its union of delta 0 infinity times q, yeah, and like this, and continue like this. For here, for every u, it means intersection of u in 0t enter q, and I will continue here for every delta which is near, for every s which is near to u, it means u minus delta and u plus delta enter q of the event omega in omega, such that xs the omega minus xu of omega modulo inferior less than epsilon, yeah. So here, this information here, of course, it's an fx till instant t0, yeah, this in this set. And so we have intersection of countable and union of countables event that there are in the sigma algebra. It's also in the sigma algebra, and we prove that it's in this sigma algebra. Yeah, something here why we worked with the interval 0 t0, yeah, and not open here and not closed, because if we worked with closed interval, a is continuous from 0 to t0, what we will prove that a it's n f x t0 plus, yes, and it's this is the filtration somehow bigger than this filtration, yeah, like here we see somehow in the future of t0. So we cannot include this t0 because we don't know what happened after t0. We know that left it's continuous, but after t0 plus epsilon we don't have any information. It can jump at that moment, and then we don't know that the continuity is still or not at instant t0, but we know at instant t0 plus we have this information, so we can include this interval 0 t0. Yeah, we can include this interval 0 such that we have this. And if we have the usual condition about the filtration, so we know that one of the usual condition is that this filtration, we suppose them right continuous. It means this equal to this. So if we have the usual condition, there is no problem to add t0 because we have this information. A good question here to end with. In the stock market, we usually in stochastic calculus we use this fxt0 as we suppose we have the usual condition, yeah, as the filtration is right, it's right continuous all the time. But is this reflecting really good the stock market? Because you don't know, at every moment we can have a jump, we can have something. So this is quite something to think about. Yeah, so I repeat, I reformulate myself. In the stock market, if we want to modelize the stock market, is it okay to use filtration satisfying the usual condition, for which is the right continuity of this filtration? Yeah, okay, thank you.